let's take a look at another CSCS sorting and searching problem. Stick length. So what's going on here? We have n sticks, some lengths, and we want to modify them so that they all have the same length, right? They're all equal. And we can either lengthen and shorten a stick, and the cost of doing that is just the difference between the old length and the new length, right? So for example, here we have sticks of 1, 2, 2, 3, 5. And we want to make them all equal. It turns out in this case, the cheapest way is to make them all 2. So that costs nothing, minus 1, cost of 1, plus 1, cost of 1, minus 3, cost 3. So the total 1, 1, 3 is 5, and then 2 costs nothing. So the answer is 5 to make them all equal at 2. If we made them all equal at 1 instead, that would cost more. Right? 1, 2, 0, 4, 1. So let's see, that's 5 plus 3 is 8. Or if we made them all equal at 3, that would also cost more, I think. 2, 2, 1, 1 would be 6. So 2 is the best value to make them all equal to. How about in general? How do we find the best value? So suppose that we start at 1. Then the total cost is just going to be like the sum of the sizes minus 1, right? Because they're all going to have to go down. What happens as we as we change from 1 to 2? Well, everything that was bigger than 1 is now going to cost 1 less, right? It used to cost 2 to change a 3 to a 1. Now it only costs 1 to change the 3 to a 2. So when you increase the target by 1, everything, you decrease the cost by the number of bigger elements than the new target, but all the 1s will now go from costing nothing to costing 1. So you increase the cost by how many things are smaller than the new target. And so if you think about it, right, we can just think about increasing the target 1 by 1. This is a good deal as long as there are more things that are bigger than smaller than the target, because you're decreasing the cost by the number of things bigger and increasing the cost by the number of things smaller. So eventually you're going to go so far that there's more smaller things than bigger things, and increasing the target is going to start increasing the cost again. Right, so we sort of have like a, V shape for the total cost. And so what is that target that has the minimum cost? Well, it's the one where there's an equal number of smaller and bigger elements. That is, it is the median of the array. Right, so we're going to sort this array, take the middle element, make everything equal to that, and that will have the smallest cost. Because that is sort of the balancing point where there's the same number of elements that are smaller than it than are equal, that are bigger. So let's do that. Right, if we chose a smaller target, then we could make it bigger and have a decreased cost. If we chose a larger target, then we could make it smaller and the cost would decrease. Because when you decrease the target, the cost goes down 1 for everything smaller and up 1 for everything bigger. Algorithm for sort. Five. Okay. Cool. So that works. Notice, by the way, right, so the middle element we're saying is n over 2. if the array is odd, this actually does pick out the middle element, right? Because, well, I don't know, it's a combination of how zero indexing works. Right, like if the array was length 3, n over 3 over 2 is 1, and indeed a1 is the middle element. If the array is even, then this picks out like the left middle element. It would have also been fine to pick out the right middle element. But the argument for why this is right is the one I was giving before, which is that if you increase this target, the cost would increase because there's more smaller things than bigger things, and if you decrease this target, the cost would increase again because there's more bigger things than smaller things, right? You want, like, the ideal target is the one with a balance, an equal number of bigger and smaller numbers on either side. It might actually be the case that if you increase or decrease the target, it stays like flat. Like for instance, well, that's not a good example. But I guess the even case is a good example of that, right? If it was if the input array was 1, 2, it doesn't matter whether your target is 1 or 2. But in any case, picking the left middle element is always fine. So that's the poem.